All right, so in the previous video, we were just starting to introduce dimensional analysis as a technique that can help you solve lots of problems, not just metric conversions, but the basic strategy has three parts. Identify the given quantity and unit. You'll start by writing this number, including the unit, on the left side of your workspace. You then need to identify conversion fractions that'll help you get from your original units to your desired unit. You will then multiply your given quantity by these conversion fractions, right? And those conversion fractions are fractions where the numerator is equal in quantity to the denominator, thus making the fraction equivalent to 1. When you multiply by a conversion fraction, the job is not to change the inherent value of the quantity, but to manipulate the units of your quantity. So you set up your equation so that your undesired units cancel, but your desired units are in the numerator and don't cancel out. Remember that units found both in the numerator and the denominator will cancel. All right. Now this chart here down at the bottom is a selected set of equalities, right? These are equivalent quantities, useful to refer to when you're solving conversion problems that are not just metric unit problems, right? So if you're looking to convert a length, these are various length measurements that can be used as equalities and as conversion fractions. These are mass equalities, volumes, and times. Okay, so that's a reference page that we might need to come back to. So let's take a look at their first dimensional analysis problem, not using metrics. So the idea here is how many feet does 19 inches represent? The idea here is to recognize the given quantity, well, 19 inches. I'm going to put this towards the left of my workspace, and I'm trying to intentionally discover what I'm trying to get to. So now 19 inches, right? Multiply that by a conversion fraction, and in this conversion fraction, we want inches to cancel out, so we're going to put that in our denominator. And we're pretty sure we can go directly to feet. We're pretty sure we can figure out that 1 foot is equal to 12 inches. So this is a pretty simple problem with only one conversion fraction. Multiply everything across the top, divide by anything in the denominator. Inches over inches cancel, and the math just becomes 19 divided by 12, and we're going to get this number here, 1.58. We're going to round that to 1.6. The unit that did not cancel is meant to be tacked on at the end here, and so that is our problem. 1.6 feet is equal to 19 inches. All right, let's go down and take a look at, let's look at number 4. We'll come back to number 2 and 3. Actually, if you want to take a minute, I'm going to have you pause the video right now. Pause the video right now. Try numbers 2 and 3. Come back. All right, if we come back, here's what you should have for number 2 and 3. Check your work before we go on to number 4. All right, let's take a look at number 4. 16 weeks are left before a student's 16th birthday. How many minutes will need to pass? So we're going to start with 16 weeks. That's the amount of time we have to figure out how many minutes that is. So we're going to start with 16 weeks, and we're going to convert that into minutes. So we're going to start by putting weeks down here. Now, weeks to minutes directly, I don't think most people would know that. I think most people would know that there's how many days are in a week, right? So 7 days in 1 week. That's a pretty common one. That would make sense. So let's include that one. If I stop here, weeks over weeks will cancel, leaving me with days. But I want to go to minutes, right? So we got to do another conversion fraction. I want to cancel days, so I'm going to put days down here. And do I know how many minutes there are in 1 day? Probably not, but I do know how many hours there are in 1 day, right? There's 24 hours in 1 day. So if I stop here, days over days will cancel, leaving me with hours, but I want to go to minutes, so I have to do another fraction, canceling out hours by putting it in the denominator, and here's where I know that in 1 hour there are 60 minutes. So that's going to be what allows me to get rid of hours and allows me to convert to minutes. So the idea here is we're going to multiply by anything that's in the numerator and divide by anything that's in the denominator. But with only ones in the denominator, this math is just multiplying everything. So this is what, 16 times 7 times 24 times 60. And we're going to get this large number, 161,280, and it's important to make sure you record minutes as your final unit. All right, pause the video here. Try number 5 on your own. There's a couple different ways you can do this by using some of the equalities on page 17. But pause the video here, and then we can check your work. All right, checking your work. Here we go. This is what you should get for number 5. Depending on how you approached it, you would end up with going from yards to feet, feet to inches, inches to centimeters. You end up with 4,937 centimeters. Or if you convert it directly from yards into meters, meters into centimeters, you're going to get this. Now notice there is a discrepancy. This is due to the fact that this is not as precise as it should be. 1 meter is not exactly 1.09 yards. And so because this is a rounded number and this really is a rounded number, they're not perfect equalities. You're going to have some slight rounding differences. Doesn't matter if you can substantiate this final answer based on this work. You've done what you need to do. All right, so let's take a look. We're going to take it up a notch and go to some more advanced dimensional analysis problems, right? So we're going to go back. This is page 19, number 7. And we're going to set this up a little bit differently. Instead of doing a bunch of fractions, I'm going to show you another way that may be helpful to help you organize it when the units start to become a little bit more complex. So number 7, fingernails grow at a rate of 1 nanometer per second. How many meters will your nails grow in a year? So we're given a length of nanometers per time of seconds. We want to go to a length of meters per year. So we're trying to go to meters per year from nanometers per second. So we're going to start by writing our given quantity, 1 nanometer. Of course, I botched that already. 1 nanometers per second. And I want you to intentionally put this in a fraction like this. And instead of doing multiplication signs, we're going to set this up where we have brackets like this. This is implied when you set it up that we are going to be multiplying by a conversion fraction. And when we have these starting units that are derived units, where we have, some unit over another unit, you have to remember that the bottom unit is in the denominator from the get-go, right? This is 1 nanometer per 1 second. That's what it means. So treat them not as 1 unit in the numerator. Treat them as a unit in the numerator and a unit in the denominator. And that means you're going to work on converting 1 unit at a time. We're going to work on converting nanometers into meters first. Then we'll go back and work on converting seconds to years. So the first thing we want to do is focusing on getting rid of nanometers. We'd put nanometers down here up to meters here. Now 1 meter is equal to 10 to the 9th nanometers, right? So nanometers over nanometers cancels and leaves us with that unit in the numerator that we want. Meters, I'm going to circle it. I don't need to change that anymore. That's what I'm trying to get to, right? So now I'm going to go ahead and set up my next fraction. This is meant to be, we're going to multiply by this next fraction again. And since my seconds over here is in the denominator, in order to cancel it, I have to put seconds up top, right? And so I want to convert seconds to years. So probably what I have to do is go from seconds to minutes, where 1 minute is 60 seconds. That'll allow my seconds to cancel and leave me with meters per minute. But I have to keep going, right? So I'm going to start another fraction. This time I want minutes to cancel, so I have to make sure I put it up here. And I'm probably going to have to go minutes to hours. 1 hour is 60 minutes. Minutes cancels. Right now my unit is meters per hour. But I want to be in per year, so I have to keep going. Hours has to cancel up here. I'm going to go from hours to days. 1 day is 24 hours. Set up another fraction because hours are gone, so now I'm in meters per days, but I'm getting closer. Days per year, I know this, right? In 1 year, there's 365 days. Days canceled. So the only units that now haven't canceled is meters per year, which is what I was trying to get to, okay? So notice, I did not do any calculator work until I set up my problem, and now I'm just going to run this through. Anything that's in the numerator, I will multiply by that number. Anything that's in the denominator, I will divide by that number. So I'm going to go through and do all the multiplication up top, and then I'm going to divide by the only number that I really need to, which is 1 billion, this 10 to the 9th power. So I'm going to start with 1 times 1, which is just 1, right? So 1 times 60, times 60 again, times 24, times 365, right? And, so that's just the numerator. I still need to divide by 10 to the 9th. So I'm going to divide by 1 times 10 to the 9th. And I'm going to get 0.03, I'm just going to round it to 0.03 meters per year. That's equivalent to about 3 centimeters per year, which is probably a little bit of an easier distance to conceptualize. But yeah, that's how you set those up. Let's take a look at number 8. You watch a mouse walk 32 centimeters in 1 second. That's the centimeters per second is the unit. How fast is this in miles per hour, right? So we're going to start with 32 centimeters over 1 second. And we're trying to go to miles per hour. So the first thing I'm going to do is convert centimeters to miles, and then I'm going to work on converting seconds to hours. So I'm going to set this up. Centimeters. Get rid of centimeters. So centimeters on the bottom, meters up top. 1 meter is 100 centimeters. Centimeters cancel. Next fraction. Meters to miles. If I go back and look at my reference chart that was in my notes, meters to miles, meters to miles. Okay, do we have that? We actually don't. We have to go, let's see, meters to miles. We have to go to, this is kilometers. So we're going to go miles to kilometers because that's what I have here. So 1 kilometer is 0.621 miles. Okay. Oh, shucks. Okay. But that doesn't cancel with that. So, all right, we're going to take this back, because that's just a little too awkward the way I presented that. Let's go from meters to kilometers first. Meters to kilometers, right? So 1 kilometer is 1,000 meters. Okay, now that I'm in kilometers, now I can use my kilometers to miles, which came from here. 1 kilometer is 0.621 miles. Okay, so that follows that logic a little bit better. That puts me in miles in the numerator, which is what I want. Now I got to work on going from seconds to hours, right? So seconds down here, so I'm going to put seconds up top. Seconds to minutes, 1 minute, 60 seconds. Seconds cancels. Keep going because I want to be in miles per hour. So minutes to hours, 1 hour is 60 minutes. Okay, so now I've set everything up where the only units left that haven't canceled are miles per hour. I'm going to multiply by everything in my numerator. I'm going to take what I get from that and divide by anything that's in the denominator. So I'm going to have 32 times 0.621 times 60 times 60. Now I'm going to divide by 100, and I'm going to divide by 1,000 again. That's going to give me 0.72, let's call it, we're going to round that to 0.72 miles per hour. Okay, so this little mouse can walk at a speed of 0.72 miles per hour. It doesn't feel very speedy, but I guess they're little tiny little things. All right, the density of gasoline is 0.743 grams per milliliter. What is the density of gasoline in pounds per gallon? All right, 0.743 grams per 1 milliliter. We're trying to go to pounds per gallon. So again, the first thing I'm going to do is try to convert grams to pounds. Grams to pounds. This is mass. Grams to pounds. So I have 1 pound is 454 grams. So I'm going to use that as my first fraction. Grams in the denominator. So it'll cancel. Pounds up top. And I see that it's 1 pound is 454 grams. Grams over grams cancels, leaving me with pounds, which is my target numerator right here. So now I'm going to work on getting rid of the milliliters. I'm trying to go from milliliters to gallons. So let's take a look at the volume. I'm going from milliliters to gallons. I see here that I can go from milliliters to quarts, and then I can go from quarts to gallons with this one. So let's use this one and this one. So milliliters, I want milliliters to cancel here, and I'm going to go from 956 milliliters to 1 quart. Milliliters cancels, and then I have to do one more where quarts goes to gallons. 1 gallon is 4 quarts. Quarts cancels, and then that leaves me with pounds per gallon. So I've got my math is set up. Now I'll bring my calculator, multiply by everything across the top, divide by anything that's in the denominator. So 0.743 times 956 times 4 gives us that number. And the only number I really have to divide by is 454. And that's going to give me 6.26 pounds per gallon. All right. Now that you've converted derived units, right, so we now have units that are perhaps useful, right? Here's a speed, 0.72 miles per hour. Here's a mass per gallon, right? So now that we've converted to these derived units using dimensional analysis, we can use these as the conversion fraction itself, okay? So we're going to try that. Let's talk about that mouse. How many miles could that mouse walk in question 8 in 11 minutes, assuming constant speed? So what we're going to do is we're going to start with the 11-minute time, and we're going to set this up so that we can use the mouse's speed to figure out how many miles it could go in a given amount of time, right? So 11 minutes. Because the speed is per hour, we're going to convert this minutes to hours, right? So 1 hour being 60 minutes. And then what we're going to do is we're going to set up this fraction here, this whole thing, 0.72 miles over 1 hour, right? Hours will cancel, giving me miles, right? How many miles could the mouse in question 8 walk in 11 minutes, assuming constant speed? Right? This is the constant speed. This right here represents the amount of time we needed the mouse to walk for. And so now the math just becomes 11 times 0.72, and then we divide by 60, right? So this mouse is going to walk 0.13 miles in that given amount of time of 11 minutes. One last question here. After filling up a 5-gallon gas can with the gasoline in question number 9, how heavy will it be? So starting with 5 gallons, right? We know that it's 6.26 pounds per gallon. So remember that's 6.26 pounds in 1 gallon. So let's set this up so that the units will cancel, gallons over gallons. And we know it's 6.26 pounds over 1 gallon, right? So the math here just becomes 5 times 6.26, right? And so the whole thing is going to weigh about 31 pounds. So the idea here is that dimensional analysis, right, is a technique that can be used to help you solve lots of problems, not just metric conversions. They help you substantiate why you are multiplying by a certain number or why you're dividing by a certain number, and it allows you to communicate or justify how you get that final answer in your unit. All right, this is a technique that we're going to be using a lot in the units to come, and so we're going to be focusing on this skill. The answer itself is okay, but it's the skill that we're going to be looking on, so I'm hoping that you're going to embrace this and use it moving forward. All right, we'll see you back in the classroom.